This is going to be our last test of the school year. Um, Everybody should be able to do well in this. So if you really pay attention to this, take notes, make sure you understand each section of this. So this first section should be very easy, provided you are in the correct mode. So how do you know which mode to be in? Look for the degrees symbol. If you see that little symbol right there, you know you need to be in degree mode. So just check on your calculator, hit mode, and make sure the degree symbol is highlighted and hit enter. Okay, so we're in degree mode. So these are the trig ratios. So the tan is comparing the opposite side, whatever the opposite length is, compared to the adjacent. So 50-degree angle, 15-degree angle should be very easy to type in. I hit the tan. So here's my tan button. And then I do a 15-degree angle. I expect this ratio to be pretty small because 15-degree angle is not that big. So the opposite side is going to be a lot smaller than the adjacent. And it tells me 0.2679. So try to round to 4 decimal places. Okay, so there's the first one. Super easy. Just as easy, sine. So sine is the opposite over the hypotenuse. Again, small angle. So sine of 10 degrees, it's about a 0.173, and we can keep this as a 6. Okay, so again, we're just comparing the sides of a right triangle when you're writing these decimals. Okay, so now this is the cosecant. So with cosecant, there's no cosecant button. We only have sine, cosine, tangent. So what you need to realize is when you see cosecant, we're dealing with sine. Okay, so we're going to take the sine, which is opposite of hypotenuse of a 56-degree angle. It tells us there's the ratio. It's about a 0.8229. But I need to flip this. I want my hypotenuse. I want the bigger side, the longest side of a right triangle is the hypotenuse. I want that on top of the opposite side. So to do that, I hit this x to negative 1. And so when we do that, we expect an answer greater than 1, and we see a ratio of 1.2062. Okay, should be very easy. And again, this was on your quiz. So I had a section like this on your quiz. So the last one is the secant. That is your cosine. So cosine, so I have to hit the cosine, compare my adjacent over the hypotenuse, which in this case, 26 is going to give me a 0.89, so on. But then I flip it. So x to negative 1. And once again, I get an answer of over 1, so it's 1.1126. Okay, so now the new part, since our quiz, we now also have to remember we're dealing with radians as well. So when you don't see the degree symbol, you see a pi, you need to make sure you take the time, hit the mode key, and then change the radians. So I hit enter. Now radians is highlighted and it's now converted to radians. So now should be very easy to be able to type in the tan 7-second caret key. That's where the pi symbol is. And then I divide by 36. And it's going to give me a ratio of 0.7002. Okay. Again, we're still comparing the opposite side to the adjacent for tan. And then this last one, once again, it's the secant, which goes hand in hand with cosine. So I have to do cosine of a 4 pi divided by 9. Okay, but then don't forget to flip it because I want my hypotenuse on top. So when I flip it, I'm going to see hypotenuse is over 5 times the adjacent. So 5 point, and we'll say 758, and we'll round this 7 to an 8. Okay, there you go. Now remember, if you want your calculator to round for you, you can hit mode and set the float. Okay, so now this was on your quiz. I already quizzed you on this section where I want all the trig ratios, okay, all 6 of them. And I'm telling you one of them. So when I tell you the sine, I am telling you the opposite over the hypotenuse, okay? And you can draw a little triangle to see this. So if I draw a right triangle, Again, it's your job to put theta somewhere. So if I refer to this angle, here's my opposite side. So that's my 7. This is the hypotenuse, and that has to be 25. What we don't know is the adjacent. So we use the Pythagorean theorem. So 25 is my largest side. So when I give you the hypotenuse, you're going to take your calculator, type that in first. So 25 squared, and then I'm going to subtract my leg. So minus 7 squared, and I hit enter. It's a 576. I'm going to take the square root of that, and it comes out to a nice 24. So I know the adjacent is 24. Now, if this wasn't if it was an ugly decimal, keep it in radical form, okay? Root 576, but again, this one came out to a nice number. So now it should be very easy. So they start out with sine. They tell us we know opposite of hypotenuse. They gave us that, so don't get the one that I give you wrong. And then right next to it, I'll have the cosecant. You just simply flip it. Okay, we're comparing the hypotenuse to the opposite side. It's a 25 divided by 7. The cosine is my adjacent, which now I know is 24 over the hypotenuse. The secant is just a flip-flop. Put the 25 on top, 24 on the bottom. And then tan is my opposite, so 7 goes on top. The adjacent goes on the bottom. And finally, cotangent. Okay, just flip it, and you get all the points. Okay, so now for number 8, I want us to go back to degrees. So I'll remind you of this on your test, that I want this answer in degrees. Okay, I don't want to find that angle in radians. So whoops, math, highlight degrees, hit enter. Okay, so just make sure you hit enter so that it's now highlighted. And now when I go to solve this one's super easy. I want x, which stands for an angle. I want to know what angle has an adjacent side of 15 and a hypotenuse of 77. Okay, so anytime we're finding an angle, we're going to hit second. So in this case, second cosine, that's what's going to appear in your calculator, and you simply type in the ratio. Okay, so when we do this, second cosine, there it is. My ratio is 15 over 77, and I get about, let's see, can you see that? It's about a 78 point, and I'll say 8-degree angle. Okay, hopefully that makes sense. Next page. This, again, is a review of something I already quizzed you on. These are right triangles. So this is right triangle trig, sine, cosine, tangent. So what we need to start off with for number 9 is, I don't know either angle A or B. So I would use the information that's given. So let's refer to angle A. So here's angle A. The side opposite is 11.7. So I'm going to label this opposite. Now, if you're looking at B, this is the opposite side. So it's very important that you don't mix up your angles. So angle A, opposite, adjacent. And then I can find what angle A is by doing the tan, because I know the opposite, I know the value of the opposite, and I know the value of the adjacent, and super easy to solve. Just like with this cosine, this time I hit second tan and I type in my ratio. And it's going to tell me it's about a 70, and we'll round to the tenths. So we'll round that 2 to a 3. Okay. That's about 70.3 degrees. And again, make sure it's in degrees. Okay. Now, we don't need trig for the rest of this. So to solve for B, I can just subtract 70.3 from 90. But now, just for the purpose of this video, I will show you how to use trig to find that. Okay. So we know, let me just quickly, and it's a positive, it's going to be 19.7 7 degrees. Okay, you don't need to show work for that, but I am going to show you the trig behind this, because if I want to find angle B, these two sides get switched. Okay, so my opposite side is 4.2, the adjacent side is 11.7. So I could ask the calculator to actually tell me the tan. I can find angle B by doing the tan of B, which is going to be 4.2 over 11.7. So let me just show you this, just to prove that we get the same angle. Second tan, so there's my second tan, and I'm going to type in a 4.2 over the 11.7. And we see 19.7, and then we'll just leave it as a 7. Now, again, I'll have to give you a plus or minus point, like a 0.1, just because it's just how rounding works. So, but we can agree on the answer. And again, you only need to use trig one time. So then the last side we don't need trig. You could use trig. I don't know why you would use trig, but you could use trig to find the missing side, which is the hypotenuse, which is little c. But I know my leg, so I'm just going to ask the calculator to take 11.7 squared, add 4.2 squared, and that should be what c squared equals. So let's do that. Let's do 11.7 squared plus 4.2 squared gives you a big number, and that's not your answer. There's no way that side could be 154.53. The last step is to take the square root. So I'm going to take the square root of that answer, and we get about a 12. So C is about 12.4, and we'll leave it like that. Okay? So that's how we solve the missing parts of a right triangle. Okay, so don't use law of sines here. These are right triangles. We're going to use the regular trig ratios. So then for number 10, I need to find little a, little b, and basically we know this angle 90 minus 55. We're gonna know right away that that's 35 degrees. Okay, so angle B is 90 degrees minus 55 degrees. That's where I got the 35 degrees. Okay, so no trig necessary to find that angle, since I know this angle here and 90 degrees. So here's where you have to decide which angle you're going to refer to. I'm going to refer to angle A, and here's the opposite side, which is little a. I don't know little a, but I do know the hypotenuse. So my biggest side is a 4. So if you get an answer of over 4, you know you messed up, because there's no way A or B can be greater than 4. So hopefully you realize sine is your opposite over your hypotenuse. So sine of 55 degrees. We now know. Over here, we didn't know the angles. Now I told you it's a 55-degree angle, and it's equal to the opposite side, which is my unknown, over my known side. So just make sure you're in degree mode. So for the rest of this, you can just stay in review in degree mode. And I'm just going to ask sine 55. It knows what that ratio should be. And the last move then is to multiply by 4. So to solve for A, get A by itself, undo division, we multiply, and we get about a 3 point, and I'll round the 3.3 units, whatever the unit. I don't label this. So if it's inches, feet, it doesn't matter, but it's 3.3. So now we can use the Pythagorean theorem. Okay, we don't need trig anymore. You only need to use trig one time when solving a right triangle. So let's use the Pythagorean theorem. I know 3.3 needs to be squared. I don't know side B, but I do know my longest side. So to type this in the calculator, I'm going to type in the hypotenuse first. So 4 squared, and then I need to subtract the 3.3 squared. Okay, hit that. That's not my answer. Do not be tempted to say that B is 5.11. Our B has to be less than 4. The last move is to take the square root of that answer. And we get about 2.3 units. Okay, so again, that's something that everybody had a chance to do on your Trig quiz. So if you made mistakes, just learn from it. Okay, so now a couple word problems. You should be able to understand the situation I'm asking. So draw a picture. We have a ladder. There's my ladder. It's leaning against a building. So the two questions I asked, I actually have two parts of this. We know the ladder is 25 feet. Okay. We know it reaches a height of 21 feet. Okay, we read that. If the top reaches a height of 21 feet, the first question I'm asking is how far away from the base, from the bottom of the building to the ladder? And then I also ask for the angle of elevation. So what angle is formed between the ground and the ladder? Well, to find this side, we just need the Pythagorean theorem. This is a right triangle, so you don't need trig to know 25 squared minus 21 squared. So let's ask the calculator to do this for us. So we'll do 25 squared minus 21 squared. There it is. So obviously it's not 184 feet away from the house. We have to take the square root of that answer, and we're going to see it's 13.6 feet. Okay, so x is 13.6 feet. Okay, so now the last question is use the sides that are given. Use this 21, use the 25 to find this angle. So hopefully you realize the opposite side is 21. The hypotenuse, the length of that ladder, is the 25. That is the sine. So the sine of this unknown angle, use a symbol, use an X. I don't care what you use. We don't know an angle, but we do know the ratio. We know the opposite side's 21 feet and the hypotenuse is 25. So anytime we find an angle, we hit second. So I hit the blue button, and then I hit sine in this case, and I just have to type in the ratio. The calculator knows what this angle has to be, and it has to be about a 57.1 degree angle. Okay, that's all we're doing. The next situation, we're standing, here's my person. We're standing 650 feet away from a tree. There's my tree. Okay. We're told that the angle from the ground, so the angle of elevation is 6.4. So from where we're standing to the top of the tree is 6.4 degrees. And I already have that we're standing 650 feet away from the tree. What they're asking for is, hey, how tall is that tree? Okay. Hopefully you realize in this case, I'm trying to find the opposite side of my right triangle. So here's where the 90-degree angle would be. And I know the adjacent. So opposite adjacent is the tan. So we do the tan of 6.4 degrees, and it's x over 650. Well, that should be really easy to solve. We ask the calculator to tell us what the tan of 6.4 is. And hopefully you realize 6.4 is a small angle. So the opposite side is going to be a lot smaller than the adjacent side just because that angle is so small. But the calculator knows what the ratio should be. It's about 11%, okay, 0.11. But then the last move is I multiply by 650. And so we know that that tree is about 72.9 feet tall. There you go. Okay. So again, you should be able to understand the situation and understand which trig ratio to use based on the sides that are described to you. Okay. Now the rest of this is 9-2 stuff. So the 9-2 stuff dealt with converting. So the first conversion I want you to be able to do shouldn't matter what degrees I give you. So it's the same move. So no matter what number pops in my head for your test, no matter what version you have, if it's degrees, you divide by 180 and put a pi. Okay, so the conversion ratio is basically pi over 180. So this is where doesn't matter which mode. We're not doing sine, cosine, tangent. So you can be whatever mode you want to be in. But it's 225 divided by 180. We get a decimal, even though it's not a bad decimal. I prefer it as a fraction, which is 5/4. So the answer is 5/4 pi. And I don't care if you put the pi up top or the pi outside or after the fraction. So either answer is acceptable. Okay, so if you can do one of those, you can do any problem because no matter what degrees, I don't care how small it is, how big it is, negative, positive, it doesn't matter. I always take that in. So in this case, negative 315 divided by 180 and it's negative 1.75. If it's an ugly decimal, it doesn't matter. The calculator can convert it back into a fraction. And don't forget the pi. Okay? That's how we go from degrees to radians. And you had plenty of practice and big ideas, worksheets. That one worksheet that you had to show me, that's where you can go back and look at some more examples. Okay, so now here we're going into degrees. So now we multiply by 180. So the conversion ratio is 180 over pi. The good news is the pi's will cancel out. So I promise you. Now, in big ideas, there was a couple where it was just a number. They didn't have a pi. Then we had physically divide by pi. But since there's a pi up top, the pi in the bottom from our conversion ratio will cancel out. So all you need to do is take your calculator, type in the fraction, so that's 31 divided by 9. You could hit enter, or I'm simply going to just multiply by 180. And I know that that's a 620-degree angle. Okay, so if I had to graph that, hopefully you realize that 9 fits into 31 more than twice. So that's why it's more than a 360. Okay, remember, 360 degrees is a 2 pi. So if you would convert that, that's it, they're equivalent. So this last one, doesn't matter if it's negative or positive. I put the pi in the bottom, 180 up top. The pi's cancel out, and I'm just going to ask the calculator, hey, take negative 5/6 and multiply by 180. And I know that's going to be a negative 150 degrees. Okay, so again, should be easy on the test. I'm only going to have two of those, so it shouldn't matter what it is in radians. You can take any number and multiply that number by 180. Okay, and that's how many degrees you're going to have. Now I'm going to have you, and again, I'm not going to give you a protractor, so just try to be as accurate as possible. We should know that a 400-degree angle is more than a 360. So we're going to have to do a full turn. So rotate and make sure you rotate counterclockwise. And then we still have to rotate. So if you take 400 minus 360, you still have 40 degrees. So just shy half of this turn. So somewhere right in there. Okay. There's where a 400-degree angle, it would be in the first quadrant. So if I ask for what quadrant it lands in, it would be the first quadrant. Okay. So now for the negative direction, we go clockwise. So we're going to have to do a full 360. And once we do a full 360, so you can see it this way. So there's my starting. If I do a full 360, we are going to be left with negative 100. So we're going to have to do a 90 degree, so a quarter turn, and then about 10% more. So somewhere down here in the third quadrant. Okay. So again, just use some, figure it out. If it's a really small or big angle, you're going to have to do complete turns and then figure out where it's going to end up stopping. So that's what I was thinking. So I'm showing the work. So full 360, then another 90 degrees, and then finally just a 10-degree turn. So third quadrant. Okay. The last two to know, again, with practice, you're going to see that negative 10 ninths, hey, well, 9 fits into 10 more than one time, so it's going to be more than a half turn. Okay, that's eventually as you get used to dealing with radians, if you take trig in the future. But my suggestion is convert this. Okay, convert this into degrees. We're just going to ask the calculator, take negative 10 divided by 9, multiply it by 180. And we're going to see it's negative 200. So that's more than a half turn. So there's a negative 180. And so once I do a negative 180, I have to go about 20 more degrees. So again, just to eyeball it up, you'll see that this is in the second quadrant. Okay. And that last one, this is going to be more than a full turn because 9 fits in the 20 more than 2 times. So again, just remember 2 pi is equivalent to a 360. We're going to convert this. I'll ask the calculator to help me out. 20 divided by 9, I'll hit enter since I didn't put it in parentheses, times 180, and I'm going to see it's 400. Okay. Hey, that's just like number 17. So 17 was exactly 400 degrees. So it's going to end up in the first quadrant. So let's quickly do that. So there's my full 360, and I need to go about 40 more degrees. So once again, it ends up in the first quadrant. Okay. So again, guaranteed to see these exact problems, just slightly different numbers, but make sure you come prepared for this last test. There's no reason why you can't do very well on this last test. So then the next part, last page, I give you enough hints to tell what that angle measurement is. Okay, so what you're supposed to realize is this is in the positive direction. So counterclockwise is it's going to be a full 360 plus you came up 20 degrees shy of 90, so that would be a 70-degree turn, and all total, it's a 430. Okay, that's all you need to be able to do. So I give you enough hints to be able to figure that angle out. So for this one, we know we're going in the negative direction. We're going clockwise. So it's a full 360. So let's do negative 360. We do a quarter turn, which is negative 90. And then we keep on rotating another negative 75. Okay, so if you use your calculator or you do this in your head, you do it in your head, it's going to be a negative 525. And that's all I'm asking for. Okay, this next set of problems, coterminal, we learned same exact position. Okay, so we're just going to rotate a full turn around and end up in this same location. So for degrees, we're thinking 360s. Okay, add, subtract until you see a positive coterminal and then a negative coterminal. So for a 206, if I simply add a 360, so I'm going to do that right away to get a positive coterminal. So 206 plus 360, that's going to be a 566. So 566 degrees. That takes care of our positive. And if I start with a 206 and then I turn it clockwise, doing in the negative direction, I'm going to get a negative 154. Okay, and that's all I'm looking for. I'm looking for a positive and a negative. So now with radians, I want my answers in radians. So with this, instead of adding a 360 and subtracting a 360, you're adding a 2 pi and subtracting a 2 pi. So when you do this on a calculator, you do not type in the pi. Okay, it's going to be part of our answer. So all I need to do, or you can do this without a calculator. You can get a common denominator if you wanted to do it without a calculator. But I do 11 divided by 18. I'm going to hit enter and then math enter, enter. I like seeing it as a fraction. So there's my 11/18. So when I add a 2, I'm going to see it's really 47/18 pi. Okay, that is a positive coterminal. So now if I subtract the 2, I'm back to my original location, and I'm going to subtract 2 again. So I see now when I subtract, I get negative 25/18 pi. Okay, So that should be very easy. Radians, coterminal, add, subtract 2. You could add or subtract 4. It's still the same, going to be the same location. Okay. The last two. This is the last topic that we will learn this year, and that is the law of sines. So I am going to guarantee on your test, I'm going to have one problem where you have to tell me the angle, and then one problem where you have to tell me the side. So for number 25, we start out by asking for a side. So you just have to realize side AB is really little c. Okay, so that's side, that's opposite angle C. So what we learned, this is nothing more than a proportion. We're setting up two ratios equal to each other. So my unknown, I'd like to write first. I don't know what side C is, but I do know, and I must know, the angle opposite that side that I'm trying to find. So I have to know that that's a 79-degree angle, and I take the sine of it. That's why it's called the law of sines. So then I must have a side. Hey, so they tell us 20 inches. So it's 20 inches, and they must tell us this, or they must give us enough clues to be able to figure out what this angle is. That's opposite the side that's given. But here I can definitely tell it's a 33-degree angle. So I should put my degree symbol. And now it's all calculator work. So, but this is worth 3 points. I must see that the proportion, the complete proportion, and how you're going to solve it is just type it into our calculator. So again, just double check. So we only needed to be in radians mode just for those two problems where we were doing the sine, cosine, tangent of an angle that was in radians. Everything else was in degrees. So I'm in degree mode. And to solve this, all I need to do is type in, let's see, there it is, type in the right side. So 20 divided by the sine of 33 degrees. Okay, just hit enter. And then all I need to do is multiply. I want this C, I want this sine going. So to undo division, I multiply by the sine of 79 degrees, and I get about 36. So C is 36. I'll even put 0.0, and it's inches. And we're done. That's the only side I'm asking for. That's all you needed to be able to do. So then the last problem, number 26, this is where I'm finding an angle. So here's my unknown. So I take the sine of that unknown angle that goes on top. I must know the side opposite. Okay, if this phi wasn't here, there's no way we could use the law of sines to solve this. But the good news is we know that is 5 meters. So I'll put an M for meters. And then I must have a complete ratio. I must have an angle and a side. So the good news is I can see a 107-degree angle. That's obviously going to be my biggest angle. And my biggest side would have to be 23. So angle to corresponding side. There's the setup. That's worth 3 points on your test. And then all you need to do is use a calculator. So once again, I simply type in the right side. So now here's where some people do mess up. Either close the parentheses at this point or hit enter. I like to hit enter. I like the calculator. Just calculate. Tell me what the sine of 107 degree angle is. There it is. And then I divide by 23, hit enter, and then multiply by 5. Okay, now this isn't the answer. Now I'm going to write this, but just realize that's not an angle. Okay, that is a ratio. And the last move, anytime we're finding an angle, I have to hit. That goes back to the first page where I'm asking for the sine of some angle equals this ratio. I hit second sine, second negative. So it copies and pastes that previous line, and I can see it's about a 12-degree angle. So I'm just going to, so angle C is about 12 degrees. Okay, that is everything that you need to know. And I am hoping it makes sense to you, okay? That it's a topic that you can feel very comfortable in the year. If you're concerned about your grade, get 100% on this, okay? So that is our last test. Then we'll hopefully have the rest of the year to get ready for a final, and I'm hoping your final can only help your grade. Okay, so we're going to go through all the big major concepts of problems that we learned throughout this year. So thanks for watching. That took 35 minutes to go through all 26 problems. We should have plenty of time to be able to do a test similar to this. Okay, so thank you for watching. Take care.